Okay, let's move on to question 3. The area of a garden is given by a equals 2 brackets x plus 3 xy squared. If x equals 5 and y equals 2, give the area of the garden. Well, this is just substitution, so a equals 2 brackets 5 plus 3 times 5 times 2 squared. Okay, let's work out our brackets. Do the multiplication first. A equals 2 brackets 5 plus 3 times, let's do our exponents first. That's 4. 3 times 5 times 4. 3 times 5 is 15 times 4 is 60. So that's 60. A equals 5 plus 60 is 65, so 2 times 65, so A equals 130. It doesn't actually tell us what the units are, but it does say the area, so we should give it in context, units squared. Okay, moving down to the next question. Simplify 3x squared plus 12x over x squared minus 16. Well, when I look at this, I can see I've got a quadratic on the top and a quadratic on the bottom. So if I factorise both of these, I'm hoping that maybe I will find out that I get a common factor in both that I can cancel. So let's factorise 3x squared plus 12x. That's going to factorise 3x squared plus 12x equals 3x brackets x plus 4, and x squared minus 16, well, that's one that I've just got to spot. I know the only way I can get rid of my x term is if my two brackets are the same, so I know that's x plus 4, x minus 4, and when I said the same, I mean the same but with opposite sides. So I know that 3x squared plus 12x over x squared minus 16 equals 3x x plus 4 over x plus 4 x minus 4, and yet those two cancel, leaving me with 3x over x minus 4, and there's my simplified answer. Okay, moving down to the last question on this page. So Georgia is designing a new logo for her sports club made up of 2 circles. She draws one circle on top of another as shown in the diagram, and we can see that the total height of the 2 circles is always 20 centimetres. Georgia is exploring what happens to the total circumference of the 2 circles when the radius of one circle increases and the other decreases. Okay, so she showed that the total of the 2 circumferences of the circles is 20 pi. Okay, so we need to find out how the 2 circumferences are linked. Well, they're linked by the radiuses. So this one is r, that's r, and this one is whatever is left. So that's the radius of this one must be 20 minus 2r, that'll give the diameter of this one, divided by 2. So we'll call that capital R. So the radius of this one is 20 minus 2r divided by 2. Okay, so now I've got an expression for the radius of this one just in terms of the radius of this one. Cool. So I know that the circumference equals 2 pi r, so I'm trying to find out the total circumferences of both of them added together. So I know that the circumference of this one is going to just be 2 pi r, and the circumference of this one is going to be this times 2 pi. Okay, that's the circumference. So C of little equals, we said it was 2 pi brackets 20 minus 2r over 2. and we said that the circumference of the big equals 2 pi r. Well, this is a bit clumsy, so let's simplify it. So actually we can just take out a factor of 2 here, so I can make that 10. So that equals 2 pi 10 minus r. Okay, so here's my circumference of my big circle, here's my circumference of my little circle. So let's add those together. That gives me 2 pi r plus 2 pi brackets 10 minus r. Okay, let's expand this, see what happens. 2 pi r plus 20 pi, 2 pi times 10 minus 2 pi times r, that's 2 pi r. Well, I've got 2 pi r minus 2 pi r equals 20 pi. So there we go, I've shown that the total height of the two circles is always 20 pi.